Alright, as I promised you guys last class, we're gonna go ahead and do some word problems regarding radicals first, simply because I feel like, hey, I know many of you aren't doing the homework, and I get pissed off every time when I mark your tests and I'd be like, oh look, that was literally one of the homework questions. So I'm gonna go ahead and bring it here and do it with you. If a rectangle has an area of 4 square units, so in this case, 4 square unit actually means the area is just 4 unit squared. So that is the area. Okay, so I just want you to keep that in mind. So its width, it's square root 7, square root 5. And now, to find the area, it's usually length times width. It's 100% length and width. So now we have the width, and we have the area. Length equals area. All we have to do is just 4 divided by root 7 minus root 5. Now, if you remember last time, this was just a simple, rationalization question. So we're gonna multiply by the conjugate. So now on the bottom, we're gonna go ahead and have. So on the top, we're gonna have 4 root 7 plus 4 root 5, and on the bottom, we're gonna have 7 minus 5, which is 2. And now we can common factor, so take out the 2, take out the 2, take out the 2, so that's 2 root 7 plus 2 root 5, and that is our length. We have finished the question. Now let's go and look at question number 16. Write a quadratic equation in the form of this. I'm only going to do question A because the rest is basically the same thing. So these are the roots. And remember, what are the roots? Roots are the x values, the x-intercepts. And when you have like a factored form, x plus a, x plus b, this is a factored form. So x is equal to negative a and negative b. This was a factored form. So in this case, all we have to do is just fill it in. So for x to have a root of 3 plus, 3 plus root 2, your last step had to be this. Alright? This had to be your last step. So now, for us to actually have 3 plus root 2, we needed to have a subtraction mark here. So this was 3. No, not that. Okay? And now a quadratic equation. And now basically what we're gonna do is we're gonna square both. So you could have done this. This was option number 1 that you had. Option number 2 was this. So we could have just squared both sides. And then we could have ignored this and be like, hey, look, plus minus root 2. Now when we square it, it's just gonna be 2. And then we have this. We expand all of this, and then we move that over, and then finally we'll have the full quadratic form. They asked us for standard form. You can go ahead and do that on your own. So let's talk about today's class. It's adding, and we're gonna deal with complex numbers. So first of all, before we start, I want to go ahead and give you an example. If you have 6 minus 3x plus 5 plus x, what are you going to do? You're going to go ahead and collect the like terms, right? So 11 and then negative 3x plus x is going to be negative. So that would be your answer. Now, you would treat basically the imaginary numbers literally the same way you would treat, you would treat the imaginary the same way you were treating a constant. So essentially you're going to have 6 plus 5, 11. And then negative 3 plus I, negative 2I. And that's our answer. You're going to treat I like a constant, even which it is. Well, x is a variable and I is a constant. You're just going to treat it like a variable. And then for 2, it's the same thing. So 2 minus 4 is going to be negative 2. And negative 3I plus 5I, because the negative cancels out, that's going to give you plus 2I. And usually when we are doing adding and subtraction of complex numbers, if we have I squared or I fourth or I to the any power that is a factor of 2, we usually will give the value of -1, -1 or 1. But whenever we have I or I cubed, we just leave it like that, simply because it's harder for us to go ahead and expand it. There's just a lot more things to do. Now we're going to multiply this. And remember, we treat it just like a variable. So this is going to be 6I plus 8I. And now, look, we can actually add them together, right? Because, oh wait, no, we can't. 6I and 2I squared. So now, 6I, but then 8I squared, I squared was equal to -1. So this is just -8. So it's -8. So usually, your teacher wants you to write -8 plus 6I. Just because they like the real part to be at the front and the fake part, well, the imaginary part to be at the second. And then you would do this FOIL thing again. You would FOIL it just like you would do to a normal variable. So 1 times 4, that's 4, plus 3I, minus 8I, and then minus 6I squared. So now you're going to go ahead and be like 4 minus 5I plus 6, because this was -1. So -1, the negative cancels out. So this is going to be 10 minus 5I. Imaginary part at last and the real part at the front. And for C, this is basically the same thing, except now we're going to use this binomial squared. We're going to use the formula, which is A squared plus 2AB plus B squared equals A plus B squared, or A minus B squared, or whatever. So we're going to use that formula. So let's go ahead. 1 squared, that's 1. And then we do 2 times 4I, which is 8I times 1, 8I. And then square that is going to give you 16I squared. So 16, that's -16. So this is -15 minus 8I. Essentially, that is our answer. And then for example 3, we're going to talk about rationalizing the denominator. So just like we learned a couple lessons ago when we rationalize a radical, this I is technically a radical. So we want to get rid of that radical. So what do we want to do? We want to multiply it by I, because then we will have a real number. So let's go ahead and multiply it by I. Let's just time I over I, because remember, I is a definite value, so this is just actually 1. So now we'll have 5I over 2I squared, which is -1. So now we'll have 5I over 2, but we have the negative in the front, because, well, I can't keep on telling my Kumon backstory, but they wanted me to leave the negative mark at the front, or they would give me a negative mark, which wasn't the funnest, but that's okay. Now we have rationalization of a binomial. So remember, whenever we want to rationalize something that's a binomial that is in the denominator, we'll multiply by its conjugates. So what is the conjugate of this? 1 plus 2I. So 1 plus 2I. So this is actually 1. We're multiplying by 1. So now the bottom would, well, okay, let's do the top first. So the top, you'll do FOIL. So that's going to be 2 plus 4I plus 3I. So plus 7I. And then plus 6I squared. And then the bottom is going to be a difference of square. So you're going to do 1 minus 2I times minus 2I. That's going to be minus 4I squared. And that's going to be plus 4I squared. Plus 4. Yeah, so plus 4. So that's going to go ahead and give you 5. So this is our answer. And then we collect the like terms at the bottom. This is a -1, by the way. So that's -6. So 2 minus 6, -4. Plus 7I. And this is O over 5. And that is our answer for this question. Let's go ahead and get rid of that. So now we're going to check imaginary roots. So because this question asks us to solve and check for it, so we actually have to go ahead and plug it into the quadratic formula since we can't solve this by factoring. But if we were only asked to check it, we could have used the discriminant. So our b in this case is 4, so that's 16 minus 4 times a, which is 1, times c, which is 6. So 16 minus 24, we don't even need to think about it. You look at it and be like, oh, look, it's a negative number. It's not actually negative 8. Oh, it is 8. It is negative 8, so I guess that. So it's negative 8. So this means it has imaginary roots. Imaginary. So I'm not actually going to plug the whole quadratic formula because that is some common sense that you should be able to do. You should memorize that formula, definitely. You should be able to plug it in yourself. I just wanted to show you that. So this, fractals. So fractals is something really interesting. Fractals is this iteration function that you're going to learn in computer science or an introductory, I would say, sequence or series class in university. So fractals is this function in a format of z squared plus c. So this is a typical fractals format. So in this z squared plus c is a complex number. It's maybe like 1i. It's going to be I, 2i, 5i, 6i, 178i, or whatever. So this factorial, it's an iteration. So for example, if I have, let's say, I have 0 plus 2i. This is going to be equal to f. So 0 plus 2i obviously is just 2i. So now this becomes my new z value. New z value. What does that mean? So instead of putting 0 here, we're going to actually put 2i squared plus 2i equal to f. So 2i squared, that's going to give us 4i squared, which is negative 1. So negative 4 plus 2i. This is our answer for, the second entry. And now, since this is another iteration, so negative 4 plus 2i, we're going to go ahead and enter this into the function and plus 2i again. Now this gets a little bit complex. So that's going to give you, 16 minus 8 minus 16, right? Minus 16i, and then that's going to be plus 4i squared plus 2i. So now you collect the like terms. That's going to give you I squared, that's negative 1, so minus 4, so 12, and then minus 16i plus 2i, that's going to be negative 14i. So that was our first 3 entries for this fractals. It was an iteration loop. So basically, your new answer becomes your next input. So I also want to take this chance to talk about something called the Fibonacci sequence. So Fibonacci's. So usually you would only deal with this if you go into a contest course, whether that be in Euclid, Fermat, Cayley, Galois, or Hypatia, whatever contest those from Waterloo. You're going to deal with this thing called Fibonacci sequence. So basically we start at 0. And the sum of the first 2 numbers will eventually add up. So 0, 0, 1. And then 0.11, and now it's 2, 3, 5. So that is a Fibonacci sequence. The first 2 numbers will add to the next number. So I just wanted to let you know that it exists, because maybe one day I'm going to put it on my test, and you're going to be so cooked if you don't know what it is. So for question number 1, I'm actually going to do J, because that actually has both adding and multiplication. So that's negative 6i plus 12 minus 5 minus 6i. So that's negative 12i plus 7. So I want you to get really, really good at arithmetics. You got to know that negative creates a positive, and positive, negative is a negative, and stuff like that. Simplifications for number 2, I'm going to do L, because that's the hardest one. So I squared minus 1 squared. We're going to have I to the 4th power minus 2i squared plus 1. So this is going to be 1 minus the I squared negative 1 plus 2 plus 1. That's going to give you 4. surprisingly, a bunch of imaginary numbers actually gave us a real definite value. That's the power of I. Really interesting. So for 4 rationalization, you should be pretty much fine. I'm just gonna do E. Why not? So 5 over negative 2I. You're just gonna multiply by I over I. So essentially, you're gonna have 5I over negative 2I squared. So it's gonna be 2. And if these numbers were some sort of factor, you'll be able to cross it out and simplify it even further. However, in this case, no. And then 4, it's basically the same idea, except you're going to do a binomial expansion. You're going to do a distributive property at the top. I'm not going to do that. It's too easy. And then 5, remember the conjugate is just switching the sign. So 3 plus 2i, that's its conjugate is 3 minus 2i. So if I have the conjugate of, let's say, x plus 4, the conjugate is always going to be x minus 4. You just have to know that. That's it. Simple for 5. 6 is very simple. You just have to do some expansions. And 7, use the discriminant trick that I told you. So use b squared minus 4ac. I did that in the last class or the class before where I talked about quadratics. But I believe I did it last class. So if you have if you're confused about it, go back to my last class. At the front, at the start of it, I talked about discriminants and how you can verify that if it has 2 real roots, 2 imaginary roots, or 2 equal roots, 2 distinct roots, blah blah blah, stuff like that. So basically, if this was smaller than 0, you would have 2 imaginary roots because you would have a negative bracket here, and that will give you imaginary. If you were equal to 0, you actually have only one root, and that being a double root, so it's 2 repeated roots. And when you have bigger than 0, you're going to get 2 answers that actually are real. So you're going to have 2 distinct real roots, and that is pretty much it. With that said, this unit is actually completely finished. I'm going to go ahead and make a video doing the chapter practice test with you guys, because I know some of you guys don't like doing practices, but remember, math is a practice. Remember, math is not a spectator sport. Please, please, please practice. If you need help, email me, ask me questions in class, or leave a comment down below. Even whatever question you have, I'll try my best to accommodate.